Okay guys, so we're going to go ahead and look at example 1. Example 1 says we're given ABCD as a parallelogram, and we're trying to prove that AB is congruent to CD and BC is congruent to DA. Now, we're going to fill out every blank in this proof here. Now, just keep in mind, your fill out the blank, word bank is right here, so you can go ahead and use it. I'm just going to go without it, so this will make our process a little bit faster. So, first statement says ABC and D is a parallelogram. Your reason is given. Second statement, the reason here is that you're going to use the definition of a parallelogram. If you go back to your definition of parallelogram, it says a parallelogram is a quadrilateral whose opposite sides are parallel. So therefore, we can claim that BC is going to be parallel to AD, and we claim that BA is congruent to CD, which is one of your word banks. So we go ahead and fill this in. Now, the next statement, actually, once we claim it, let me go ahead and mark this here so we know it's parallel, just in our, so we keep in track of it. Now, on the next statement, we claim that angle 1 is going to be angle 1 is going to be, we claim that angle 1 is going to be congruent to angle 4. And we also claim that my angle 3 here is going to be congruent to angle 2. The reason why we can claim this is because if you guys remember, whenever we have parallel lines with a transversal, then this angle right here and this angle right here and this angle right here, they are called alternate interior angles. That's the relationship with angle 1 and 4. Same thing with 3 and 2. If we have angle here and angle here, that's also alternate interior angles. So therefore, we can claim that this statement right here is true to the alternate interior angle theorem. Okay, so we got this. Now, moving on. Let me go ahead and clear out everything first. Okay, so we know that they're congruent. So let me go ahead and mark it, okay? So I know this is going to be the same angle measurement as this. I know this is the same angle measurements as this. Now the next step, we say that AC is congruent to AC. So look at here, we claim AC is congruent to AC. This is the reflexive property, so we go with this. And next, let me go ahead and label it. This is congruent. Okay. Next step, it says that my triangles A, B, and C is congruent to triangles C, D, and A. So it's talking about this triangle, It's talking about this triangle right here is going to be the same as this triangle right here. Now, if you look at it, how can we prove that they are congruent? If you look closely, you realize that we can prove it through angle, side, angle, because we have a pair of angles that's congruent, another pair of angles that's congruent, and we have a side in the middle. So it makes our congruency through angle, side, angle. Okay, let's go ahead and erase this. Okay, now, once we know it's angle, side, angle, let's see how can we use this to prove this following. We're trying to prove that AB is congruent to CD. Okay, AB is congruent to CD. Now, we already proved in the first step that these two triangles are congruent. Then, if these two triangles here are congruent, then their corresponding parts will also be congruent. This means if you look at your statement right here, your AB is actually congruent to CD, its corresponding parts. So we know that congruent to corresponding parts of congruent triangles are going to be congruent. So we can claim AB is going to be congruent to CD. And same with BC and DA. Well, if we know that these two triangles here are congruent, then we know BC and DA are going to be congruent as well. Because if you look at your congruent statement, which is given right here, BC is corresponding one is DA. So we can go ahead and claim that BC is congruent to DA. They are congruent. The congruent parts of congruent triangles are congruent. And that finishes our proofs. Let's look at the next one. Example 2 here, we're given AB, C, and D is a parallelogram. We're trying to prove that AC and BD bisect each other. Now, first of all, when it means bisect, this means that this and this have the same length, and this right here have the same length. Just keep this in mind. Okay, now let's read this. So, first statement, ABCD is a parallelogram. That's a given. Great. Next one, it's claiming that AB is going to be parallel to CD. Well, let's check. AB, is it parallel to DC? Well, we know this is for true because we know in a parallelogram the opposite sides are parallel. So this is true, and we're going to put for our reason the definition of a parallelogram. Because we know a parallelogram has, its opposite sides are parallel. Okay. Next, we're claiming right here that angle 1 and angle 4 are congruent. Well, angle 1 and angle 4 are congruent. Now, and we're also claiming that angle 2 and angle 3 are congruent. Let's go step by step. Looking at angle 1, angle 4 first. We know from previously, this line and this line is parallel. So if you look at these two angles closely, you realize that with this transversal here, it makes angle 1 and angle 4 alternate anterior angles. This is why they are going to be congruent. Now let's look at angle 2 and angle 3. Okay, this is my parallel lines. And I have angle 2 and angle 3. If you look at it closely, you realize that angle 2 and angle 3, with this transversal line right here in the middle, you realize that angle 2 and angle 3 are also alternate anterior angles. So they are also going to be congruent. So for my reason right here, claiming why they're congruent, I'll put alternate anterior angles. Okay. Next one. Now let's look at our next statement, and let me, draw everything that I already claimed so far. So I know this is parallel. I know that this side is congruent. This angle is congruent to this angle, and this angle is congruent to this angle. Now, next statement says that AB is going to be congruent to DC. Now let's look at why this is going to be true. Now, if you go back and read your parallelogram theorems, you realize that it says here that opposite sides are congruent. And this is why we can claim that AB is going to be congruent to CD. So for my reason here, I'll put definition of a parallelogram. Okay, let me put this down. So I can claim now this is going to be congruent as well. Okay. For my next statement is leave blank, but it says that I use ASA. That means angle, side, angle. If you look at your picture, I have angle, side, angle. Angle, side, angle. So I prove that these two small triangles right here are congruent. This one and this one. So let me write this statement down. So I can say that my triangles are congruent. Let me write out my congruent statement. B is the same, its corresponding angle is D because it's congruent angles right here. And I know that A's corresponding part was C. And the last one they both have in common is E. And now I write my statement out. Now you realize that once you wrote your statement, you realize that it's none of these right here. And it's because it's a little bit out of order, okay? If you look closely, you'll realize that your triangles right here, this one, it's the same as this, except we just put it in a different order. So it's totally okay. Okay. Now, on my next reason, it says, for my statement here, for my next one, let me go ahead and erase with this messy picture. It says my AE is going to be congruent to CE. And it says that my BE was going to be the same as ED. Now, the reason I can claim this is because on the previous statement, I just proved that these two triangles are congruent. So therefore, if you use your congruent statement here, you will see that AE, and your congruent statement is right here, is congruent to CE, which is your congruent statement right here. So therefore, they are congruent. Let's take a look at BE and DE. Well, BE is right here and here. On my congruent statement, this is congruent to DE, which is right here and here. So therefore, you can claim that they are going to be congruent. And the reason is because corresponding parts of congruent triangles are congruent. Now, once you claim they are congruent, let's label it. Okay? Now, on next one, you put definition of a bisector. Bisector means we have a line crossed through it. It makes my segment into half and half. So this means if this happens right here, that this is a half, this is a half, this is a half, this is a half, then this means the line AC and the line BD bisects each other. And that's going to finish my proof for 9.1.